All right, greetings everyone. Welcome to the second part of the video for section 7.3. Continuing on with our study of the double angle identities and looking at solving some equations now using them. So here we're asked to solve sine of 2x equals sine of x for all solutions, and we're looking for the variable x here. Now notice this one will require a double angle identity because if we look on the equation, we see there's a 2x here. Also, on the other side of the equation, right, notice that there is not a 2x. And so it's hard to solve an equation when you have the things inside of your trig functions are different. So we'll go ahead and then apply our identity, our double angle identity for sine of 2x, which says we can rewrite this as 2 times sine of x times cosine of x, which will then equal still sine of x. And as I've mentioned in the past, it is very tempting to divide both sides by sine of x here to cancel out the sine of x's. We do not want to do that. If we do, that will cause us to lose some solutions, so we won't do that. So what we'll do instead then is subtract sine of x from both sides of the equation. Okay, when we do that, on the right-hand side, sine of x minus sine of x, those cancel out and just give us 0 equals. On the left-hand side, even though there's a sine of x in this term here, we can't subtract away the sine of x there because this first sine of x is being multiplied by a cosine. So we'll just have 2 times sine of x times cosine of x minus sine of x. Then notice both of our terms now contain a sine of x, so we can factor that out. So we'll have, whoops, not that color though. We'll have sine of x times, and that's supposed to be a bracket. Let me draw that better. We'll have 2 cosine of x left in the first term when we factor out the sine, and then a minus 1, we factor out sine from the second term, equals 0. And notice we have 2 terms being multiplied to equal 0. So we can solve this by taking each term and setting them equal to 0. So we'll have sine of x equals 0. 2 times cosine of x minus 1 equals 0. In this second equation, we can isolate the cosine of x. So they give us cosine of x equals 1/2. And then now we go about solving. So think about our unit circle, because I think all of these values are on the unit circle. So we have places where sine is equal to 0 on the unit circle, and that would be at both 0 radians or 2 pi radians. Those are the same thing. And also pi radians, right? Those would both be places where sine is equal to 0. In the second case, where cosine is equal to 1/2, it's a positive 1/2, so we know we'll have an answer in the first quadrant, which would be pi over 3. Then also one in the fourth quadrant, which is the other place where cosine is positives, which would give us 5 pi over 3. And then again, remember that we're being asked to find all solutions here. So we need to add some stuff to these. And in the case of the pi over 3 and the 5 pi over 3, since they're in the first and fourth quadrants, we can just say x equals pi over 3 plus 2 pi k and 5 pi over 3 plus 2 pi k. And then for the 0 and pi, well, we could do 0 plus 2 pi k and pi plus 2 pi k. But notice if you think about on a unit circle, right? 0 is here and pi is here. And if I start at 0 and go a distance of pi, well, I'd end up at a solution. And if I go a distance of pi from there, I'd end up at another solution. And then another distance of pi, another solution. Another distance of pi, another solution. I could keep going around. So it looks like if I start at 0 and just add pi's, multiples of pi, I'll get to solutions every time. So in that case, I could write my second solution here. Instead of 2 separate, I could write it as 0 plus pi times k. But 0 plus pi k is just going to give us pi k. So those would be our answers there for x. Okay. All right. Let's do another example. So here we're asked to solve cosine of 2 beta equals sine squared of beta. And here we're just doing it on the interval 0 to 2 pi. And notice again, we've got a 2 beta here and a beta here. So those aren't the same. So we'll need to use a double angle identity. And again, for cosine, there are lots of options, right? There's 3 options, I should say. And we're thinking about which option to use. Well, notice over here on the right, we see a sine squared, which tells us we should use the option for the double angle identity for cosine that uses sine. And so in this case, we'll use the one that says cosine of 2 beta is equal to 1 minus sine squared of beta equals, 1 minus 2 sine squared of beta equals sine squared of beta. And then we need to isolate the sine of beta here, which we can do by first adding 2 sine squared beta to both sides. Okay, so these can cancel. We have 1 equals on the right-hand side. We have a sine squared beta plus a 2 sine squared beta, which give us a 3 sine squared beta. Can isolate the sine squared by dividing on 3 on both sides, dividing by 3 on both sides, which will give us 1/3 equals sine squared beta. And then to undo the squared there, we know we could take the square root on both sides. And remember, when we do that, we always get 2 answers, a plus or minus. And so what we end up with here then is sine of beta equals plus or minus square root of 1/3. And in this case, because the square root of 1/3 doesn't come out nicely, and if you simplify it, it won't give us one of our root 3/2s or root 2/2s or anything like that. I'm just going to leave it like that for now. And again, we can break this into 2 kind of separate problems here. We would have sine of beta equals positive root 1/3 and sine of beta equals negative square root of 1/3. And again, because these do not lie on the unit circle, these values we'll have to use our calculators and inverse sine. Now I'm not going to go through all the specifics for that on this first one. But when we do that with the positive root 1/3, we'll get an answer in the first and second quadrant. So we'll get 0.6155 and 2.5261. But I do want to look at the second one. So when we do inverse sine of here, what I'll end up getting if I do inverse sine of negative square root of 1/3, my calculator will give me negative 0.6155, which is not in the range of answers we're looking for, right? That's not between 0 and 2 pi. Mostly it's negative. So we have to think about then, where is that on the unit circle? Well, we took a inverse sine of a negative answer, which tells us we're getting an answer in the fourth quadrant, negative 0.6155 there. But again, we want it to be in the range of 0 to 2 pi. So the way we can do that is just by adding 2 pi to it. So we can do 2 pi plus minus 0.6155. Okay, that'll get us in the correct range. When we do that, we should end up with beta equals 5.6677. Okay, so that'd be an answer in the fourth quadrant. But we also know that sine is negative in the third quadrant, so we need to find an answer there. And how would we do that? Well, we need the reference angle for our angle in the fourth quadrant, which since our angle was originally negative 0.6135, we know that the reference angle will just be the positive version of that, so 0.6135, which means our angle in the third quadrant will be 0.6135 radians beyond the horizontal, which remember the horizontal is pi. So what we're really looking at for finding our other answer here is doing pi plus 0.6135. And when we do that, I believe we get 3.7571. Okay. And so those are our four answers in this case: 0.6155, 2.5261, 5.6677, and 3.7571. Okay. Awesome. Thank you all for watching. That's it for now.